New footage of Elon Musk's Colossus AI Megafactory is going viral right now. And if even half of what you're seeing is real, this isn't just a bunch of computers. It's a brand new kind of industrial machine, because the headline claim is absolutely ridiculous: 200,000 GPUs in one cluster. And if you're thinking, okay, I've heard big GPU numbers before, stay with me, because the GPUs aren't even the craziest part. The craziest part is what it takes to keep 200,000 GPUs alive, synchronized, and training, without turning the whole building into a giant toaster. And the newest clips making the rounds hint at one detail that changes the entire story. In a second, I'll tell you what that detail is, and why it suggests Colossus isn't the endgame, it's the warm-up. Into space and next-gen tech, consider subscribing. It helps a lot. Alright, what is Colossus, really? Colossus is xAI's supercomputer cluster, built to train the Grok family of AI models. xAI says it was built in 122 days and then doubled in 92 days to reach 200,000 GPUs. 200,000. And here's the first thing most people misunderstand. Colossus is not one computer. It's a warehouse full of computers that are forced to behave like one brain. Tens of thousands of servers, miles of cable, a networking fabric faster than most countries, internet backbones. And, according to reporting, it was built in Memphis, Tennessee, inside a repurposed industrial facility, a former Electrolux manufacturing site. That detail matters because it explains how this could happen so fast. Now let's break this down in 3 escalating wow levels. Wow. Number 1. 200,000 GPUs is not a flex, it's a logistics problem. A typical AI training server holds 8 GPUs. So 200,000 GPUs can translate into something like 25,000 GPU servers. Then you stack those into racks, and suddenly you're talking about thousands of racks inside. An enormous building. This is why people call it a megafactory. Because it's not just a machine, it's a factory that produces intelligence by grinding through math 24/7. And xAI's own numbers hint at the supporting systems too. Massive storage and enormous network bandwidth per server. But okay, here's the obvious question. Even if you can buy 200,000 GPUs, how do you make them work together? Because at this scale, the GPU isn't the bottleneck. The bottleneck is time. And wasted time in a cluster like this doesn't just cost money, it costs momentum. Which brings us to, wow, number 2. The timeline is the real shock. NVIDIA said the supporting facility and supercomputer were built in 122 days, then described 19 days from the first rack arriving to training actually starting. 19 days. That's not Silicon Valley planning, that's industrial sprint. So how do you pull that off? You don't do it like a normal corporate project. You do it by removing every unnecessary step, standardize the design, run crews around the clock, treat the data center like a production line, rack, cable, test, repeat. And here's your first mini cliffhanger. The hard part isn't only getting GPUs. The hard part is connecting 200,000 GPUs so they don't spend half their life waiting on each other. Because if the network is slow, your GPU's idle. And if your GPU's idle, you're burning a small fortune for zero progress. So, what's the secret weapon? Wow, number 3. The GPU is the engine, the network is the drivetrain. At Colossus scale, the network decides if the system is a supercomputer or a very expensive space heater. NVIDIA says xAI's Colossus used Spectrum-X Ethernet, built around ultra-fast switches and network cards that let servers move data directly with very low latency. And NVIDIA claims the cluster sustained around 95% throughput with congestion control, without training getting wrecked by packet loss and traffic collisions. If you don't speak network nerd, here's what that means. Imagine 200,000 students trying to solve one homework assignment together, except they can only do it by constantly passing pages back and forth. If the hallway is clogged, nobody finishes. That hallway is the network. So Colossus isn't just a bigger GPU pile, it's an attempt to build a warehouse-scale brain where the hallway never clogs. And now, the viral footage starts to make sense. Because the clips people are sharing don't just show racks, they show thick hoses, liquid lines, cooling towers, industrial piping. And that brings us to the part most people forget. Heat, the hidden enemy, cooling. Every GPU is basically a tiny electric heater. Scale that to 200,000 units, and you're not dealing with computer heat, you're dealing with factory heat. That's why so much modern AI hardware is moving toward liquid cooling, because air just can't. carry enough heat away when racks get this dense. And it's also why the Memphis site is constantly discussed in the same breath as water. Reuters reported the build includes an $80 million water recycling plant. The Greater Memphis Chamber described that XAI's expansion follows that same path. Build the compute, then build the support systems that keep the compute from cooking itself. So when you see footage of huge cooling equipment, that's not a side detail. That's the difference between the AI is training and the AI is offline. Now, remember earlier when I said the viral footage hinted at one detail that changes the entire story? Here it is. It's not only racks and servers, it's batteries, lots of batteries. In the clips, you'll see these massive blocks lined up like shipping containers. Those aren't there for decoration. They're there because the real boss fight isn't AI, it's electricity. The real boss fight, power. Let's be honest, a 200,000 GPU cluster is not limited by software first. It's limited by electricity and cooling. The Greater Memphis Chamber described Phase 1 reaching full operational capability with 150 megawatts of grid power through a new substation, plus another 150 megawatts of Tesla Megapack batteries integrated for backup and ride-through. That is not big tech office power, that's city slice power. And the plan described for Phase 2 points toward a second substation and a path to roughly 300 megawatts of total capacity. Some estimates compare that kind of load to powering hundreds of thousands of homes. Now here's the messy part. Before full grid power was available, reporting and local accounts describe temporary natural gas turbines being used on site. That triggered major backlash and political heat, with community groups raising concerns about air pollution and permits. The Associated Press reported the NAACP and the Southern Environmental Law Center sent a notice of intent to sue over pollution concerns tied to the facility. So on one side, you have the future of AI. On the other side, you have a very real question. What does it cost a city to host a machine that eats electricity like this? Because at this scale, AI stops being software. AI becomes heavy industry, and heavy industry comes with heavy politics. Which leads to a bigger question. What does a 200,000 GPU brain actually do? Here's the simplest way to think about it. Training a frontier. AI model is basically one loop, repeated over and over. Show the model data, make a prediction, measure how wrong it was, update the model, repeat millions of times. More compute means you can do that loop faster, run bigger models, try more experiments, and iterate at a speed smaller labs just can't match. That's why Colossus matters even if you don't care about Grok. Because whoever controls the fastest iterate cycle tends to control the direction of the technology. And that's why XAI didn't just rent cloud GPUs and call it a day. This is a bet that owning the factory beats renting the factory. Now, here's your second mini cliffhanger. If Colossus is 200,000 GPUs, then what happens if XAI actually builds the next step? Because the newest headlines suggest Colossus isn't a one-off. It's a template. The twist, 1 million GPUs and a 2 gigawatt plan. Multiple reports describe XAI aiming for a roadmap to 1 million GPUs in the Memphis area. And on December 30th, 2025, Reuters reported Musk said XAI bought a third building to expand its infrastructure, targeting nearly 2 gigawatts of training capacity. 2 gigawatts. That's power plant territory. Reuters also described plans to turn that warehouse into a data center in 2026, alongside a Colossus 2 effort near a natural gas power plant XAI is building. So Colossus isn't just a supercomputer story anymore. It's an energy and infrastructure story. Own the building, own the power plan, own the schedule. Iterate faster than anyone can rent. Whether you love that idea or hate it, it points to a new reality. The AI race is turning into a construction race, a grid race, a permitting race. Now, let's do the promised reality check without killing the hype. Is 200,000 GPUs real? According to XAI's own Colossus page, that's the stated count, and NVIDIA publicly discussed. The system scaling from 100,000 Hopper GPUs with XAI doubling toward 200,000. So this isn't just a TikTok rumor. But here's the nuance. GPU count doesn't automatically mean 200,000 identical H100s. Real deployments mix. Models, generations, and sometimes people talk in H100 equivalent terms that blur the math. And new footage doesn't always mean shot yesterday. Viral clips are often reposts and recuts that resurface when a fresh headline hits, like the multi-gigawatt expansion talk. So yes, the title is sensational, but the underlying reality is still wild. AI is becoming heavy industry in real cities, on real power grids, with real consequences. And that might be the biggest wow factor of all. So here's my question for you. If the next generation of AI requires power plant scale infrastructure, should it be treated like normal tech or like public infrastructure with more transparency, more oversight, and bigger rules? Let me know what you think in the comments. And if you want a full breakdown of what a 1 million GPU cluster would actually look, like how big it would be, how much power it would demand, and what it could do, hit like, subscribe, and I'll see you in the next one.